found it. Oh, I just left in the paper towel anyways. Whoa, did that paper towel just light up? I mean, it is a wand. It's not magic, it's just induction. Faraday's law states that a change in magnetic field and therefore change in magnetic flux can induce something called EMF, or electromotive force, which can drive current and power something like light. I know what a magnetic field is, but what's magnetic flux? And why do you get music and I can't explain that. That's just like physics or something. But let me hand you over to the whiteboard to you, she can explain the rest. Magnetic flux is simply just the amount of magnetic field that passes through a given surface. We can quantify this with 3 different variables: magnetic field for B, the surface area for A, and theta, which is the angle between B and A. Now, if one of these 3 variables do change, we have a change in magnetic flux, and therefore we have EMF, and therefore we have electricity. But Faraday's law does not stop there. It has to become so much cooler. You see, before this, scientists were led to believe that electricity and magnetism were 2 completely separate things, never intertwined. But then Maxwell comes along and derives 4 fundamental partial differential equations which show that electricity and magnetism are actually driven by one another. He found that these 2 things actually create a wave function. He saw that Faraday's law of induction, a change in magnetic flux that produces an EMF or electric field, was very similar to the modified Ampere's law, which a change in electric flux produces a magnetic field. And so when he saw these 2 similarities, he said that if one of these changes, then the other has to change. If that changes, this changes, if that changes, and he saw that it was a self-sustaining driving force. And he called this an electromagnetic wave. But it gets even cooler. You see, when Maxwell was deriving this wave function, he found that its velocity was equal to 1 over the square root of mu naught multiplied by epsilon naught, which are 2 of the fundamental constants in physics. When he calculated this number, he found something very interesting, that it was equal to 3 times 10 to the 8, or the speed of light. It was then that he decreed that light was an electromagnetic wave. But that's enough history. To understand why it's important today, let's talk about Lenz's law. Lenz's law states that the induced current in a conductor produces a magnetic field that is opposite of the change in magnetic flux. That is why we have this negative sign here in the EMF equation. Now, if you can see in this video, I'm pushing a magnet in and out of the solenoid, producing a positive and a negative magnetic field, which in turn creates a fluctuating current in this cosine wave, and that is how we get alternating current. And that is why Faraday's law is so important. It is how we take kinetic energy and convert it into electricity, something we can use. It is the reason why you are watching this video right now and how every single thing in your house is being powered. So I kind of understand why people think that Faraday's law is magic.